Good afternoon, everyone. My name is George Barnich. I'm Vice President and CTO for Manufacturing Technology Deployment Group. You might not be aware of them, but it's basically the holding company for the National Center for Defense Manufacturing and Machining, and they are primarily known for running the America Makes Institute. So if you've heard of America Makes, then you've generally heard of us. So what I'm going to do is tell you about a program called AM Now that was commissioned by the DoD in the United States. And it's not about a lot of sexy parts. It's about cost and coming up with open standards and dealing with the supply chain. I think. So to be clear, if you're familiar with the digital thread, there's a lot of aspects to the digital thread. What we were focused on was sourcing, production, and delivery. So we weren't dealing with the design up front or things like that, or there's a lot of CAD companies that provide a lot of software with that. And in terms of maintenance and sustainment and disposition, you got ERP, MRP systems that deal with that, and it's generally very robust in the digital thread on those two ends. Where the digital thread tends to fall apart is when you start sourcing parts out to the supply chain and then getting that digital data back. And that's what this program was focused on. So if you just look at this graphic, it's really kind of trying to explain. You have an OEM and a tier one supplier. Generally, they have enough money to pay for high-end proprietary software platforms, and they stay relatively well securely and digitally connected. But once you start going into tier 2 and tier 3, basically what you have emails, FedEx packages, and a very rudimentary way to communicate with your supply chain. So a lot of that in the red is part of the problems with that is very limited security. You have certain specific ways to get export control data from point A to point B, and generally the proprietary platforms are too expensive for these small manufacturers, and I'm talking people with 5 or 10 people in a shop. In the United States, 97% of the industrial base is under 500 employees. And about a good 86% of those are under 20 employees. So you can imagine the supply chain in the United States is thousands and thousands of small manufacturers that really don't have the revenue or the expertise to be able to be digitally connected like the tier 1 suppliers are. So this is essentially what we implemented. You can see the digital information transport system. We just basically put an application up in the Azure Gov Cloud, and this is up in GCC High. And the other piece of it is you see these IoT systems on the bottom, which are essentially where the machines were not connected before, now they're connected. And we provided these. This was a $3,000 item, a 3,000 euro item, no recurring license fees, and no mandatory maintenance fees. And they were able to get the data off of the machines and sensors and things around the, if you were to try to get that commercially today with installation, you're looking at about 5,000 to 8,000 euros, depending upon how complicated it is. And what it did is it provided a complete digital thread that reached down into the suppliers. And if you notice, one of these boxes just needs to be on the Ethernet switch, and you can have multiple machines, so it wasn't you had to buy a $3,000 box for each machine. Didn't work that way. So if you'll notice too, there's 3 differences. You see an air gap, which is typically a DoD configuration, which means there's no connection to the internet from that IoT system. It's just in the manufacturing network. The other is a dual network card that's resident in, and basically you've got a firewall between those dual networks, and then some people implemented it with a workstation between the internal manufacturing network. This is a very important part of this because when you deal with defense work, you don't want to be just tethered to the internet constantly. So how did it work? Basically, we functioned as an OEM DoD customer, and we started sourcing parts, and what we did is we securely delivered a tech data package, which was really drawings, sometimes 3D drawings and requirement specs, some of the specs we had to create because they didn't exist, and pushed it to the secure platform. The supplier pulled it from the secure platform, produced the parts. The IoT edge device captured the in-situ data, pushed it into a local database for the manufacturer that the manufacturer manages, and then based on the contract, they would submit manufacturing process data that was agreed to ahead of time for each contract. And then that was pushed into the cloud. We or the OEM, say a Boeing or a Lockheed or a US Army, would be able to pull that data back and then put it behind their firewall. So consider that secure cloud platform like a secure buffer for information. And as you can see, some of the data that was included, feedstock, the 3D printer data, which was the time series data that came out of each of the machines, thermal treatment, smoothing, machining, so you could see it was the full gambit of information. So those two shots on the right-hand side are actually screenshots from the platform that were created, but there were over 200 suppliers that were registered for this project that we did. We had about 110 different individual contracts that we completed. About 67 of them had the IoT systems in place, and we did 29 different use cases, did them from all the different types of parts so that we could do different materials, different processes, and so forth in order to demonstrate a very robust system. And basically about 304 builds, over 2,000 parts, and a whole lot of coupon tests that were in this database. Some of these are out of the 29. I was able to obtain 6 public release versions so that you guys could see, but just realize that this is 6 of 29, so you can imagine what the other 23 were. So as you notice, in some cases we used multiple materials, but in most cases it was multiple machines and different builds. And the idea of that was just to see how the parts, the single part that you wanted, what kind of different types of parts you would get back from the same set of technical data packages. There's another 6, just basic items that we had been, given by the Army to use as use cases. So as you can see, different machines, different manufacturers, different types of machines, and multiple builds for each one. So in order to make this work, we had to create these AMNow specs on the right-hand side because unfortunately, digital data deliverable formats don't exist. There are specifications for what data to collect based on certain KPIs, but there's no specs that tell you how to format them so that they're machine readable and usable by, say, a platform. So as you can see, those were all the different processes that we had, and we created these for them. So bottom line is, you get an as-installed part model, the buyer would provide those, and the supplier comes back with the finished parts, coupons, and then delivers the test data. It was all done through this secure platform in the GCC High. So as a result, what happened, we used a very clever naming convention, Excel. It was very simple tools. There wasn't a single proprietary item inside the entire system, and that included Azure. We didn't get lazy and use the tools up in Azure. We wrote them ourselves so that we could port it over to AWS or possibly Google in the future. So that's the idea. The point here was, can you do this without being tunneled into a particular proprietary solution? And so all the data that was presented for each of the builds was there on the right, and the engineers were very easily be able to just click on them and approve them. So basically demonstrated an ability to accept parts based on digital data deliverables. So we were fortunate enough to find that the testing companies were very eager to provide the data in the format that we wanted in simple Excel spreadsheets that made it easy. The common headers were really what ties everything together in the entire system. We could, it was when the data was loaded, the platform automatically parsed it and put it into a database, and the engineers were allowed to view them with the tools that we provided, or they could export them in any number of different open standard formats. So there wasn't a lock on any of it. So as far as conclusions of where we got with this project is we found that a lot of the machines that were provided or that were part of the program had all different kinds of output types. So those are not standardized. You got OPC, you have some MT Connect. Even the different versions of the machines had different data inside the serial data stream. So you can imagine not having the standards was a huge problem. The subcontractor that provided the IoT system was really busy hustling around adding additional parameters every time the OEM of the machine decided to add more parameters or change it. So standardization in this area is going to be key if this is ever going to be used in industry. With regard to the ASTM specs, it tells you what the data reporting requirements are, but the actual standards for digital data formats don't exist, and that's really the next key thing. I presented yesterday at the ASTM conference that they had, and this is going to be an initial thrust that's going to happen now, is to try to standardize these formats so that now all of your analytics tools can just parse them out and make it a lot easier and automated. Like I said, we had 3 labs that were willing to provide us the data the way we wanted it. It was ingested, and it was a huge amount of time that was saved with this. So bottom line is, standardizing these data formats is really going to save a lot of cost, and it doesn't sacrifice any intellectual property or any competition sensitivity. When we first started this, there was a lot of reluctance to do this because they didn't want these things in there, stealing valuable data from them. But the point is, the contract determined what data was provided, and the supplier was in charge of the data that was provided. So it was a push, not a pull, and that allowed us to get over the cultural problem of providing in-situ contract data deliverables. One of the things we did was just to see how valuable some of this data was, because we did it really to implement the platform and to show how easy it was and to see if the small manufacturers were willing to do it. So we basically had, we took all of our 316L data and put it out there in a data challenge, and what happened is these AI companies took the data and tried to resolve patterns and things inside the data, and then when we evaluated them, we hand-selected a few of them and said, now go back to the original manufacturer that built those parts and provided the data and show us that somehow you improved their processes or whatever. So basically that was done. One of the biggest things that came out of here is that organizing the data took 80% of the effort. I mean, quite honestly, if there was a standardized format, that 80% cost would go away right away. And there were improvements in productivity and the mechanical corrosion properties. So when we got the new parts back, there were improvements based on the AI machine learning that was provided. So it's definitely true that the capability of this will improve AM parts going into the future. So basically, to sum this up, if all the machines have to be qualifiable and certifiable, and right now we're doing 100% inspections on everything, okay? And the idea here is, after time, once you start collecting this data for the same types of products, you're going to see patterns with the data and the product, and then you're not going to have to 100% inspect them and do x-rays and radiographs. That's really the whole purpose of this, to just lower the cost of qualification and certification, which is the biggest challenge for the Department of Defense. We also demonstrated that one of the first feedback we got was, if we ask for digital data for these parts or monitoring, that the cost of the parts were going to go up. And we demonstrated that that is actually not the case. So the part unit cost does not increase because you ask for in-situ data and digital data deliverables. The suppliers are willing to do it. So we had over 200 of them willing to play. As long as they get paid, they're generally willing to do it. And it's really going to be the buyers of AM parts that are going to push this. They need to push and drive for digital data standards like we created, and ours will be like an initial starting point for creating those. We're going to donate those. And the buyers really need to put that in their contracts, add another line item in there and say, you will provide a digital data deliverable. And remember, all of those are negotiated by contract. So if you have a high value, high dollar part, you're probably going to be required to provide more data. If you have a part that's not that critical, it'll probably be a lot less data, but you let the free market determine what data is provided at what cost and so forth, rather than trying to tell people how to do and how to do it and what to do. I think this is last but not least. So we created these templates. We made an arrangement with one of the subcontractors that we had, a Barnes Group. I believe they're at this show, so they were our technical lead on this. So we agreed to co-own them and release them as open licenses. And what we ask is that when people use them or want to add improvements, that there's a public website on the America Makes core, which was recently released, and hopefully we can grow these standards and then, or preliminary standards, and then hand them over to ASTM and SAE and let them become formal, real standards. So if there's any questions, I'd be happy to answer some. No questions?
If anybody would like to ask a question, I'll do my best to run the microphone out to you. There we go.
Is this presentation data available on the web page or something?
Yeah, this is a public release. I don't think I have it posted, but I think we could put it on the America Makes core public site.
Yeah, that would be great. It needs to be downloaded and digested.
Yeah, I know. I did. 20 minutes wasn't a lot of time with questions, so I tried to hurry and give 4 minutes for questions. It was a lot of material to go through, so apologize for that.
Oh, no, very interesting.
Okay.
Any other questions? Where are they best tracking you down after this? If they think of something.
I don't know. I'm going to run away is what I'm going to do. No, I'm kidding. If you go to that, to the America Makes core, one moment, core.americamakes at AM Now specs, you'll find the actual specifications. I actually had them in my ASTM presentation because a lot of geeks there and they're into it. I wasn't sure what kind of audience I would have here, but I'm not sure you want to look at. But it was very, very comprehensive, and it's not it wasn't done as a game. It was done to actually create to try to help Battelle move some of the SAE standards, and we actually had 9 of them that we pushed out of this program based on what we were doing. Really what it comes down to, if all the buyers in industry have access to these specs and they're willing to put a contract line item that says, hey, you're going to deliver some of this, you can deliver that data in an anonymized form. It's really the material properties data. It doesn't take your secret know-how away, but it really helps develop design minimums. And that once we get those, people are going to have a lot easier time creating compliant parts with these types of specs and standards.
And one more from me.
Sure.
When you finished here and you walk off onto the show floor.
Yeah, it's the second time you're asking me the same question.
and you find something, your dream innovation, be it a piece of software, something that fixes your biggest problem. What is that?
I think what would fix the biggest problem right now is to have an IoT system that can talk to any manufacturing equipment that there is, and that every time the equipment manufacturer adds more information or changes it, it automatically gets updated, because quite honestly, that's most of the work. So everybody has different proprietary standards that they use, and unfortunately it prevents progress. And from an industry standpoint, that's probably the most key item, is to be able to get the data off of the machine in a way that you can use your own third-party tool rather than having to pay a license for a proprietary tool.
Well, there you go. If anybody wants to go and develop that in their spare time, you have a customer on stage. So thank you very much.
Yeah, you're welcome.
Okay, we now have